Hello, hello. So yeah, I'm Radoslav Stankov. You can find me on the internet with my initials. And today I'm going to tell you how the product hunt front-end application is structured. But before that, before going to the deep technical stuff, context is always the king. It's always great to know how something happened in its history. So a bit of history. Product hunt developer team consists of 7 people. Everybody is full stack. Everybody works together in the Ruby backend, together on the front-end app, and a couple of people actually work on the iOS part as well. So initially, Product Hunt, when I started working at Product Hunt in 2014, it was an almost Rails application. It has jQuery spaghetti. The first thing I did was adding some backbones with some half-baked component library we used. But this very quickly outgrew us, and in February 2014, we switched to React using a gem for Rails called React on Rails. And we started converting our pages to React. We started having small components here and there, and those components started hitting our whole application. Around May 2014, Flux became a thing. Unfortunately, Flux just became like something like a whisper. There wasn't like any library, so as everybody, we wrote our custom Flux implementation, which was helpful, but in December 2015, we switched to Redux, mostly because we needed to have server-side rendering, since React actually have eaten most of our application, and now pretty much all our pages were React pages. Because of that, in January, we actually started doing client-side routing, and we started using the React router. And during this period, our code became a bit more messy, so we introduced something called Redux, which I'm going to talk about later today. And then we have like a silence period because we needed to clean a lot of legacy stuff. So the next step of our evolution became at January 2017, when we actually removed React from our Rails app, and now we have a separate front page application which just does server-side rendering. This year was very busy. We introduced GraphQL in February. We added code splitting in March. And pretty much this is like the state we are currently at. It's now May, and hopefully we don't plan any major changes to next January. So the next thing which it's important to know about the Product Hunt app is how it's structured on the server side. Like, I'll talk mostly about our front-end part, but it's good to know how the backend works. So right now we are currently on Heroku. And in one Heroku dyno, we currently have 3 things living there: an Nginx server, an Node.js application, and a Rails application. So why do we have those 3 things there in a single dyno? So first, when the browser requests an HTML page, the Nginx, we use it as a proxy. It calls the Node.js app. The Node.js app is producing the HTML for the page, and it gets the JSON from the Rails application. When the user have already loaded the app and is just clicking around, we don't need to do full page refreshes. Then the browser just wants JSON as data, and Nginx just forwards to the Rails application. And this is how our server-side architecture works like. But today I'm going to focus more only on our JavaScript and on our front-end application, and I would leave the back-end stuff for some horror conference or something else. So this is how our front-end application looks like. This is our current directory structure minus the legacy folder, since I wanted to have a pretty picture. And let's see what we have here. So entry.js is the starter file of our application. It's pretty much what boots the whole application. Config.js, for some surprises, does the configuration of the app. The utils folder is our junk drawer of like random functions. We try to keep it only with like pure functions and with like stuff which doesn't like evolve anything else out of it. We do a decent job there. The lib folder is more like plugins for libraries like Redux middlewares, stuff we want to open source someday but don't have time. Styles contains our basic CSS variables, our base style sheet, some CSS functions. And now we go to types. This is a bit like types in JavaScript. So this is the first interesting folder we actually have. So we use something which is called Flow. It's by Facebook, and it adds a type system on top of JavaScript. So you can do stuff like that. You can define a type, and this type, you can say, OK, I have these fields. The ones with question marks means they can be null, or they cannot be null if they don't have a question mark. So how do you use Flow? So when you define the function, you add type annotations. For example, this function checks if you accept a current user object and a topic user, and it returns some Boolean. So if I call it in any of those three variants, where I give it null for user or topic, or I don't give it a topic, during the compilation, when we convert our nice ECMAScript JavaScript to whatever works on a browser JavaScript step, we get a failure, our build fails, and we have to fix that. The other nice thing is, if we try to assign this, to use this Boolean as a number, also no go. So the only real usage is we have the variable, the Boolean, and it returns. Nice thing about flow type is it uses a structural type system, so it doesn't depend on classes. So you can actually define your function just by the stuff you use. So I can here pass the user object, or I could just say everything which has the following properties. As made by Facebook, like flow type has some nice integration with React, very surprisingly. So let's say we have this very interesting component. It's an user image, and the user image has two variants of using it. One, you give it size, and the other, you give it a variant. And what happens if you use the normal prop types and you call this? Which is the correct version you try to get? Are you getting the small image? Are you getting the 50 pixel sizes? What? Like, both of those cases, like, I cannot tell you until I actually look at the code. And that's usually a bad way of designing an API and libraries. So we don't want that. So with flow type, we can define a props property, and we can say that it can accept one or the other. It can either accept a user with white and height, or a user with variant. And this actually helps us a lot when we make our components. We have a lot more freedom what to do, and flow type was a definite win, and keep our sanity in check. The other interesting thing is, as I told you before, we are using Redux. It helped us a lot in structuring our application. Nowadays, we are actually removing a lot of reducers and a lot of stuff in favor of GraphQL. But we still have all our Redux stuff in the modules folder. And we used a structure called Dux. By the way, all the links, I have a slide where I list all the links. So if everybody's interested, you can just take a photo of that. So Dux is not a library. It's just a way of structuring Redux. So basically what our modules are, this is some of our modules. So Dux have this idea. You have a module, and this module file is the name of your reducer. And it contains the stuff in this order. First is your action constants. Second is the action creator functions. Then is the reducer itself. And then it has selectors. And 5 is like you can put random stuff there, like whatever you need. So this is a very simple, this actual reducer from our application. It's quite simple. It has a constant. It have like receive notice, it can set a notice, it has a clear notice, and it's quite simple. This is how we test our stores. We actually test them in integrational way. We don't split them into parts. The way we test it is we create a fake store, we call the actions, and expect that those actions change the state the way we expect it to change. But now for the meat of the presentation is our actual React component, since this was actually part of my title of the presentation. So yeah, we use React, surprise. So this is Product Hunt right now. This is how it looked yesterday, I think. So let's see how this part of our page looks like. So if we look at our page, we have a top page component, and inside there is something we call an infinite scroll. It's like a generic component for infinite scrolling. We are very imaginative with all the namings. We have something with a even more imaginable name like code box, which is a box. And the interesting part, we have a topic list, which has topic items. And the topic items is also a component which has its own structure. The topic item just have a topic item, and inside we can find a link to the topic. We can find the topic image, the title, and the description of the topic, and a follow button. And this is pretty much how most of our components are structured. This is how it looks like pretty much our component. We use a lot of functional components, and if you use functional components, the prop types are from Flux are, okay, yeah. No lasers. You can actually define what prop types are expected, like annotations on the method name. So let's deep dive here. So the first interesting thing is here for the class name, we use something which is called styles.item. So very early on, I didn't put it on the timeline because I actually forget when we start doing it. We started using something called CSS module. CSS module is something very simple. The idea is you have a small CSS file which lives in the same folder where your React component lives. And you can actually import it. You can import the CSS file into your JavaScript, and you can access all the class names by keys. Then during the compilation process, two files are produced. The first file is the CSS file, where all the class names add this random bullshit in the end. The idea is you don't want any collisions. For example, Product Hunt, I think we have like 30 or 40 item classes, which pretty much have the different endings. And on the class name is also replaced, so you can actually use it. This is very useful because you actually know what's every CSS class which is used is next to the component it's used. And if we remove the component, we remove the class with it, and we don't have any worries about, okay, I have 1,000 selectors and I have no idea what's used where. Also, it helps with naming. I can pretty much name some class name to be named item, which in every good other practice is very stupid, because if you have one class item, you cannot have any other class items. Okay, so let's deep dive more. What are those featured and text components? So very early on, we have a lot of designers on our team, and as you all know, designers really like to invent new styles when it comes to font and font sizes. Sorry if there are any designers you really like that. So we decided that we would have like a style guide where we have only 6 variants of the main fonts used. And we would encapsulate those usages in components. So every time a developer needs a different font, you can always have one of those 6 sizes. And the nice thing about it is very nice when you can speak with it. Now we can tell to the designer can tell us, I want a headline which looks like that, and we just take the headline. I want a bold text, and we have a bold text component. I want a secondary text, not very obvious, and we already use it. And yeah, those add more elements with more classes, but this actually improved the way we build pages a lot. Now I don't have to think about what kind of styles, what kind of other stuff we have. And in general, we try to make all the stuff as generic as possible, like the box component, like pretty much the whole website we currently have is just boxes. Okay, let's continue downwards. The next interesting thing, is the topic follow button. This is actually the component which is the first component I'm going to show you today, which actually does something. And when you click it, user starts following a topic, surprisingly. And this is how it looks like. It's a bit more complicated because it has a bit more logic. So what kinds of properties it accepts? So obviously it accepts a topic. so to know what kind of thing we follow. It has a check if the user is logged in or logged out, because if the user is not logged in, he cannot follow. He has to log in beforehand. So the last three properties here are action handlers. In our case, open login full screen. This would open like a pop-up where we can ask the user to log in. We have a follow and unfollow actions. The component itself is also quite simple. The meat of the component is just our generic button, which has an active state if the topic is followed, or if not, if it doesn't have it. And it has on-click handler. We actually try to name all our handlers handle something, so when we read the file, we actually know what it does. You can see this data test property. We use it in our acceptance testing. So when Selenium starts clicking, we don't reference class names because we don't know the class names. So we just add all these data test components. So I can say, OK, click me this test button, the other test button, and all that stuff. And it has some text. The click handler is a bit more complicated. So what it does, it stops the button. It checks if the user is logged in. If the user is not logged in, we present it a login pop-up. We give the reason to the user why he should log in order to follow this awesome topic. If the topic is followed, we unfollow it. If it's followed, we follow. And yeah, that's pretty much what the component is. One thing you should notice is that we don't export this component by default. We export it named, because this is not the whole file. So so we need all those four things. We need to know if the user is logged in. We need to know the open handlers for the login. We need to know. We need to have the two actions for follow and unfollow. And here we use something which is called create container, which is a bit of a wrapper around the Redux connect function. It just has more descriptive names. So so those two codes are pretty much the same. We have rendered components. We have the action creators listed. We have the map state to props. But create container has a bit more tricks up his sleeve. We have stuff which is called decorators. The idea here is we just can decorate our components with high-level components on top of them. So for example, we have knowledge like render not found if some condition is done. We render login while this component is fetching its data. We can add a class name to the body. We can change the document title. We can, for example, hide this component if some feature is unenabled. And we have a lot of decorators like this. And for our component right now, what we do is we get an open full screen Redux action, because this is because our module system, like models, are passing through Redux. We have map state to props, which gets the current user and it checks if it's logged in. And we have this weird thing, GraphQL create mutation and GraphQL remove mutation. This is actually the meat of the object. This is what actually is doing the real work here. So a bit about GraphQL, I would move to describe it. So this is something we start using in February, and right now it's a big time saver. So what GraphQL does is you have a single endpoint like post/GraphQL, and you can send it like in the request body, you can send it a query. This query can look like this. And think about it like a JSON template. So the GraphQL server would get this query, and it should return the same data, but with the fill-in blanks. Just think about it like a template for JSON. And the way it's done is that every piece of data can actually be nested quite a bit, and every component can request whatever it wants. So GraphQL has one very interesting feature, which is called Fragments, which the query which look like that can look like this. You can split it into parts, and each part can be provided by a different component. For example, our button needs 3 pieces of data. It needs the ID of the topic, it needs the name of the topic, and it needs to have a checker if this topic is followed or not. We can imagine an image fragment which just says the image needs the image of the topic. The topic item, the one which we started on, needs the ID of the topic, the name of the topic, the description of the topic, plus whatever it's in the button and in the image. The nice thing is it doesn't care if you have duplicated properties. It will shrink them up into a single call. And in this way, you can build your components without them knowing what their children are needing. And in the end, you can say, I need the topic and I need the data for the item. So this is something which will come later. The other interesting and the most confusing part of GraphQL is called mutations. It's great that we can able to fetch the data, but sometimes we need to get this data from somewhere. It's good to get the data, but sometimes we need to change it, we need to modify it, we need to make it more useful. So the mutations is a similar call. You think about it like an RPC, where you make the query, for example, follow topic, you give it some input values, and in the end you get a new topic which you can get query against its data. So we used a library called Apollo for connecting the server-side GraphQL with the client. And Apollo provides those decorators called GraphQL, very imaginative naming as well, where you can get your GraphQL files, your queries, and you can give them options. Like, for example, here, this is how you follow a topic. This is how it looks. It's kind of confusing in the first time, but it's kind of useful. And we put our GraphQL files inside our components. So every component knows about how to execute the mutation on the data it works with. Every component can get the data it needs. So here is the same mutation, just defined as a file. We are a big believer of testers, especially me, in testing. And this is how we test our component. So we get it. We get the component here. The component, we test the actions itself. So we just take the component naked without any GraphQL. And we just use test spies to test to call our, we just test that the spies are being called when the action appears. We actually have a library called Chai and Zoom, which gives you very nice test selectors. Another interesting thing is this is how we structure our components. We have folders. The root component is named index. We have styles. We have the fragments, and everything lives together as a one unit. So when we rename the component, those components those changes can propagate. This is how the topic items GraphQL would look like. We just import the other GraphQL pieces, and we assemble it. So this was GraphQL. Let me quickly run to the other stuff. So we have routes.js. We use the React router, and most probably we'll stick with version 3. And we added code splitting. So for code splitting, our routes look like this. We have this require and sure. This is something which Webpack will take and split your JavaScript bundles. For every route, it will get you a different file. And during runtime, it will combine them. Actually, it works very magical. I have no idea what it does like there. Another interesting file is called path.js. It's something I have never seen anybody do this, and it's so simple. So you know how we have all these routes, and usually you pass them as strings. So path.js, we have just one exported JavaScript object with functions for every route in our application. Very simple file with type annotations. So we can actually import paths, and this is how we generate our routes everywhere. So if we change a route, the function can blow up. We have type safety from flow, so we actually know all the follow things which are used. Another interesting folder is called layouts. Layouts is, for example, this ProHunt again. If you look at its layout, this is how component looks like, component layout. One interesting thing is only the red parts changes most of the pages. So in layouts, we have a couple of different ways this content is structured. So it's just like a separate thing. And the last folder I'm going to talk about today is called Pages. So again, this is one page of Proluchant. This is actually our most important page. And if you look at it, it has quite a bit of data. Like, it needs all this data. I actually don't know what's all the data we actually need. If we put it into component-wise, this is all the components we have currently. We have header, we have media, we have makers, we have related posts, we have discussions. This is a very complex page. It's very important and very complex. This is how the page looks like directory view. Like, we have all this nesting and nesting and nesting. And how do we fetch all the data? So we fetch all the data with GraphQL. The way we do it is we have a fragment file in every component. It's always named fragment. And the fragment for post discussion says, I need the comments of the posts, and I need those information about that information about it. I need the user information for every comment. And this is the discussion part. The recommended post item is a bit more complicated. We get the first 10 recommended posts. We get the recommended post item data, whatever it is. We don't care about it. It's in the another file. And in the end, this gets assembled into a page query. This is the way we execute the query itself. We get all the stuff we need. We get the metadata, we get the discussion, we get the header, the maker data, the recommended post. We assemble it into one big fat GraphQL query. And when this goes to the server, all this template is filled in, and our component gets the data as a property called data, surprisingly. This is how the page component looks like. We have, again, create container. We have our decorators, like setting tags. It gets the tags from the post and set all the metadata, like OG image, OG title, and so on. We have a visible if. For example, if you try to find a post which doesn't exist, we show a 404 page. We have this thing called deferred render, which is like our loading indicator. So while data is fetching, we can show you a loading screen. And then we have our query with the ID of the post. So yeah, that's pretty much what our structure looks like. So thank you. That's all. All the slides are already actually on this address, so you can actually check them out a bit more slowly and like see all the stuff. Okay. When everybody's done taking photos, I would move. Okay. All right, that's encouraging. Okay, again, when you take the links, this is all the links of the stuff I talked to you about. And again, thank you very much. I don't know, do you have time for questions?
We have time for questions, yes.
Okay, great.
First applause.
Thank you, thank you.
Thanks for your talk. Are there any questions? Please raise hands. 2 here. Where is the microphone? In the meantime, I will ask a question. Hans Wurst is asking, why did you choose Flow over Typescript?
Very simple. Flow had features which Typescript doesn't support at the moment, like nullables. And also Typescript is, back then was all or nothing situation, and we actually started adding Flow file by file. For example, our tests don't use Flow because it's taking too much time for them.
Thanks. It was here.
So in my opinion, one of the greatest benefits of using React is the idea of separation between presentational components and container components. So why are you not using this idea?
Very simple. The problem is when we are using components, when I'm user of a component, when I use a component, I actually don't care if it's a container or not. I just want to use the component with its props. And when I'm importing a component, if I have to think, okay, was this a normal component? Is this a plugin component? Is this a component from X? It breaks my flow. Also, very often we change between container components and DOM components. And I don't want to rename folders. It's actually boring and it looks quite bad in the diffs.
It has a great impact on the performance. And when you have separated the components, you can test them easier.
Yeah, I mean, we test all components we currently have, and it hasn't been any performance issues. Like for us, if it's a container or not, if it's a performance problem, we fix it. But usually they're not, because they're not very complicated in general, at least the ones we have.
There was a second one somewhere here.
There is one here in front.
Okay, then take this one.
Yeah, maybe I overheard it, but when you said that, like with the classes, you auto-generate prefix to them, doesn't make the debugging styles harder?
Debugging, I mean, not very much. Like when you debug it, it uses the compiled class name, so I can just click on, like during development, I can just, there is link and I can click in it in the Chrome developer tools.
Okay.
In production, it's a bit harder, but usually I know which the component is. If you use the React dev tools, you actually know which is the component, and knowing the component, you actually have easier time to debug because it has like 5 styles.